So we're talking about complex numbers and the complex plane. And I want you to understand that if I represent a complex number graphically, I can think of that as a vector, something that looks an awful lot like a vector. Vectors are defined again by their magnitude as well as their direction. We can recall from vectors that r, or the magnitude, is equal to the square root of x squared plus y squared, and theta, which is our direction, is equal to the inverse tangent of the vertical component over the horizontal component. So I can represent, in other words, complex numbers in a what we call polar form by identifying this relationship here. So if I were looking at this expression, r cosine theta plus I sine theta, this expression right here is the polar form of a complex number. Kind of makes sense because we have magnitude and direction as well as the real portion of our complex number, which would be along the x-axis, and the imaginary portion of our complex number, which would be along what we think of as the y-axis. Sometimes you see this abbreviated as r cis theta. And so what we're going to do in this first example is we're going to take something that is already written in polar form and convert it into rectangular form. Now what do I mean by that? So we're going from polar into rectangular form. So if I take it out of this polar form here and rewrite it in rectangular form, the complex number in rectangular form would look like a plus bi. So we're just going to see if we can kind of simplify this. It's fairly straightforward since we already have the expression right here. Let's look at this for just a moment. Do I know how to take the cosine of 135? In other words, does the angle theta 135 exist on my unit circle? Is it something I can do in my head? And sure enough, it does. I know that because I've memorized this already, that the cosine of 135, which is over in quadrant 2, would be negative square root of 2 over 2. And the sine of 135, which would be the same thing, is I times the positive square root of 2 over 2. And then we're going to just multiply that by the number 10. So we distribute 10 in here. You can see that this is going to be negative 5 square roots of 2 for the first term, plus 5 square roots of 2i for the second term. And that's all the question is asking. Take it out of its polar form and rewrite it in its rectangular form, which has its real and imaginary parts there.